Gene Cernan. Gene's the only American to go to the moon twice. Did on Apollo 17 when he landed and walked on the moon, our most recent moonwalker, and also Apollo 10, the flight that did everything Apollo 11 did except for land. Gene was here in this very room in 2009 when this committee, in a bipartisan manner, fought to save the last mission to go to the moon. It was called Constellation. We saved the crew capsule in that battle, but Gene is very adamant. The best reason to go to the moon is because that's the best place in the universe to train for going to Mars. He pointed out a few things. First of all, the gravity. The moon is about 1/6 of our gravity. Mars is 1/3 of our gravity. To train up there, it's much better training than in a pool outside the Johnson Space Center. It's real training. In fact, the first steps on the moon were steps. They started hopping. They realized I can hop quicker and go places quicker by hopping instead of walking. He also pointed out that we found out long after we left the moon, there's water on the moon. He said, we don't know what we don't know about the moon. And it sounds like all of our panelists agreed that the moon is a good starting point to go to Mars. In fact, I think the quote from you, Dr. Looney, was, the moon is a stepping stone for Mars. And Brother Gerstmeyer, you said it's a proving ground for Mars. So could all of you go into detail about the benefits of us going to the moon to get us to Mars as quickly as possible? How was the moon tied directly for us going to Mars? Gerst, you up first.
I think, first of all, that the moon is, in a proving ground sense, is a great place for us to check out the technology to go beyond the Earth-Moon system. To build the rockets that need to go there, they can have application moving forward. We can test them and check them out. It's also good from a risk standpoint. Today, we're very comfortable in low Earth orbit, where if something goes wrong on station, we can be back in an hour or so, hour and a half. When we go out to the moon, we're now 5 days away. That's a challenge, but it's not months away like it is when you go to Mars. So learning how to operate, build the procedures in, build the stuff that the control center folks do in Houston, and understand how to operate around the moon will be absolutely critical to build those skills, to build the technology and prove it before it absolutely positively has to work as we go towards Mars. And I think it's very strong in that sense.
Mr. Stranslow, sir. Thank you, Gerst.
Thank you, sir. I would add to that one of the best things that one needs to do in order to get good at something is to practice, and to practice consistently. Being able to be 5 days away, being able to make the missions that we're doing, and to be able to do them in a frequency that we can actually learn, develop, reiterate, improve what we're doing, and do it again, allows us to get much better much sooner. So being able to go to the moon and doing all the things that we've been talking about for the last 2 hours is very good. Being able to do it on a frequency that we can actually take the things back and do it better, it really makes it a much more feasible and practical path. And what it does is actually gets us to Mars sooner rather than later. Thank you.
Dr. Lunine. Sorry about that.
Thank you. Yeah, thank you, Congressman. So a number of technologies, as Mr. Gerstenmaier mentioned, radiation safety. If we spend a long time on the surface of the moon, we're going to have to deal with shielding that will also be critical for transits to Mars. The environmental control and life support systems for long-term stays on the moon will also be applicable directly to Mars. We talked about habitats as well. We talked about crew health and aspects of in situ resource utilization. Even though on Mars it would be primarily for the atmosphere, there are aspects of it we would use, we would test on the moon. Now let me also say that successfully using the moon as a stepping stone, bringing humans back there, working and exploring on the moon, provides a success that the public will see and recognize as a critical moment that will then project us onto Mars. And we made that point in the report. But let me say personally, as a 12-year-old watching, 13-year-old watching Gene Cernan and Harrison Schmitt in the last Apollo mission exploring the moon for 3 days, I felt inside of myself that we were going on to Mars and that I would be a part of that. And even though we're here almost 50 years later and we're not on that journey, going back to the moon, working on the moon will create that same sense that, yes, we can do that for Mars that I felt back in 1972.
Thank you, sir. I'm sorry, Dr. Sanders and Mr. Faulkner, I'm out of time, but one comment about Dr. Lanuti's comments. There's a big radiation belt between Earth and Mars. It's called the Van Allen radiation belt. No human being has ever gone through that intense radiation. So it sounds like Mars has something like what we've experienced in the space station and radiation that we kind of take for granted because we've been so short in terms of our time on the moon or in the space station compared to a trip right now to Mars with our current propulsion systems. Thank you, Madam Chairman. I yield back. Go Navy.